Okay, so today what we're going to be working on is adding and subtracting algebraic fractions. But today we'll only be working on adding and subtracting algebraic fractions with like denominators. Okay, so what I would like you to do is to put me on pause. I want you to try this. And just remember that when you add fractions, you do have to have the same denominator in order to add fractions. And when you do have the same denominators, all you have to do is add or subtract the numerators and keep the denominator. Okay, so give it a try and then come back and let's check your answers. Okay, so let's take a look at number 1. We have 2 over 5 plus 8 over 5. So I notice that my denominators are the same, so I just add the numerators. So 2 plus 8 is 10. And I keep the denominator over 5. Now I notice I have 10 over 5 and that can reduce to 2. All right, let's take a look at 2. 7 over 10 minus 3 over 10. So I subtract the numerator. 7 minus 3 is 4. Keep the denominator, which is 10. And then 4 over 10 reduces to 2/5. Okay, so let's take a look at number 3. So this is just subtracting polynomials. So remember, when you subtract polynomials, you have to remember to distribute that negative. So I have 8a minus 4c plus 7a minus 3b minus 6c. So combine like terms. So 8a plus 7a is 15a. I have minus 3b, no other b. And then 4c minus 6c is negative 10c. Okay, so now we're going to put all this together with algebraic fractions. All right, so let's take a look at what we have to do. So it says to add or subtract the numerators. Remember, if you are subtracting a polynomial, you need to distribute the negative. Keep the denominators. Now notice, I'm doing the operation with this. I'm doing the operation first, and then I'm going to factor and reduce. Where when we multiply and divide, we factored and reduced first, and then multiplied. So it's kind of opposite, okay? It's the other way around. I don't want to reduce first, because if I reduce first, then I won't have the same denominators in order to add. Okay, so let's take a look at number 1. I have here 3x over 5 plus 4x over 5 plus 3x over 5. So I add all the numerators and I keep the denominator. So 3x plus 4x is 7x plus 3x is 10x. So that's 10x over, keep the denominator, which is 5. So I have a monomial in the numerator, so I can reduce. There's multiplication in between 10 and x, so I can reduce 5 to 1, 10 to 2. So my answer is 2x. All right, let's take a look at 2. 9a over 7b minus 5a over 7b plus 3a over 7b. So 9a minus 5a is 4a plus 3a is 7a. So I have 7a, keep the denominator 7b. So I have multiplication in between 7 and a and 7 and b. So I can reduce 7 and 7 to 1 and 1. So my answer is just a over b. Okay, let's look at number 3. Okay, so number 3, all I'm doing is adding. So I'm going to keep my denominator, 2x squared. So I'm looking for like terms up here. So I have an x squared, no other x squared. I see I have a minus x to the 4th here. And then negative 5 and positive 5, that will become 0. So now what I notice, I can actually factor x squared minus 4. GCF is x, and then I get x minus 4. I cannot factor 2x squared. But remember, there is multiplication in between x and the parentheses and 2x squared. So what I can reduce is x and x squared reduced to 1 and x. And that's it. So I have x minus 4 over 2x. Okay, so let's take a look at number 4. All right, so I noticed with number 4, okay, that obviously my denominators are the same, so it's 9 minus y squared. But now what I need to do is I have to distribute this negative because I'm subtracting. So it's going to be minus y minus 15. Okay, so in the numerator we have 7y minus y is going to be 6y. And then negative 3 minus 15 is negative 18. So now I notice I can factor the numerators. The GCF is 6, and then it's y minus 3. The denominator is the difference of two perfect squares, so that's 3 plus y, 3 minus y. And then remember there's multiplication here and here. So you look at, first you look at the 6. 6 does not reduce with anything. I don't have a 6 or a 12 or anything. So I go to the next thing, y minus 3. I don't have y minus 3, but I have 3 minus y. So those are opposites. And opposites, remember, reduce to negative 1. So then in the numerator, I'm left with 6 times negative 1, so it's negative 6. Remember, I put the negative with the bar over 3 plus y. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.